All right, class, welcome back. More area. Here we go. We're building up from very basic shapes now, and we're moving on to what we call composite figures, okay? So a composite figure, we say, is a figure that is made up of simple shapes, such as triangles, rectangles, trapezoids, etc. What else? Rhombuses, parallelograms, anything that we've done in the last two videos, I would consider a simple shape, all right? Now, to find the area of a composite figure, you just need to find the areas of the simple shapes and then either add them or subtract them depending on what's called for in the picture, okay? So we're going to do several examples of adding first, and then we'll move to some examples of subtracting. Cool? Here we go. Let's start with number 1. All right, number 1, and for all of these, my first suggestion would be figure out what you got. Okay, if I look at this, I'm seeing two simple shapes. A p-gram, parallelogram, and a triangle. Okay, I'm seeing two shapes, parallelogram, triangle. Well, just like what our notes say to do, we need to find each area of each simple shape first, and then add or subtract them. So if I look at my first shape, it is a parallelogram, which means I would use a equals base times height, and I already have them. All right, so this is really straightforward. The base is 8, the height is 5, a equals 40 feet squared. Awesome. Let's move on to shape 2. Triangle. A equals 1/2 base times height. A equals 1/2. Plug in the 10 and the 5. Well, area equals, either go to the calculator or do in your head, 5 times 25 feet squared. Last thing I would have to do, I'd have to recognize that my composite shape here is made up of both of them. So I would add them together, okay? So 40 plus 25 equals 65 feet squared. And you're done with that problem, all right? Not too bad, hopefully. Okay, moving on to number 3. There's a couple ways to do this. I would want to use the least number of simple shapes possible. I mean, I see a triangle and a rectangle and another semicircle. If you want to go that route, go for it. I think it's extra work. I would rather just use this trapezoid and this semicircle, okay? So, we're going to find the area of the trapezoid first. All right, so the area is equal to 1/2 sum of bases times the height. Uh-oh. I don't know the height. What do I got to do? Who remembers? I hope all of you. All right, what we need to do, guys, is we need to use what we know about triangles and trigonometry and Pythagorean theorem to help us solve this. All right? What we can remember is if this side right here is 3, okay, then over here is also 3. And if this is 3 and the whole piece is 7.8, well, whole minus part gets you the other part. So what I can do is I can draw a right triangle. And I know that the height's 4.8. And I know that the hypotenuse is 10.2. And I know that I'm looking for the height of the trapezoid. Okay? So we would go ahead and we'd use Pythagorean theorem. 10.2 squared equals 4.8 squared equals h squared. Plus h squared. My bad, guys. All right, and then go to the calculator. 10.2 squared is 104.04, and that's equal to 4.8 squared, 23.04 plus h squared. When we subtract 104.04 minus 23.04, we get a nice number. 81 equals h squared, which, when we square root both sides, we get that that value we wanted was 9. All right, that helps us, and it's actually going to help us for the semicircle too. All right, we now know that the height of this trapezoid that's kind of tilted sideways, tilted sideways, has a height of 9. So now we plug everything in. 1/2, 3 plus the original base 2, the whole thing, 7.8, excuse me, and 9. Go to the calculator. 0.5, 3 plus 7.8, 9, 48.6. All right, 48.6 feet squared. Now, for shape 2. That's a semicircle. We just talked about semicircles. Semicircles have an area formula of pi r squared, and then you have to divide by 2. Because pi r squared is a circle, we only want half of it, so you have to divide by 2. Oop, I didn't mark that, sorry. All right, so now what you have to recognize, we found that this distance across the trapezoid was 9, which is also the distance across the circle, or the diameter of the circle. So what do I do to get from diameter to radius? I divide by 2. I know that when I work through this, I'm going to need to use 4.5 for my radius. All right, 4.5 squared. If I would get 20.25 pi over 2. If I divide that by 2, I get 10.125. For right now, I'm just going to leave it like that. All right, so the area is 10.125, and remember that pi has to stick with it. All right, so you could absolutely write 48.6 plus 10.125 pi. I'm okay with it. 48.6 plus 10.125 pi. Remember what else you can do, though? You can always punch it in and decimal approximate. So 48.6 plus 10.125 pi, 80.4. And what were our units here? Feet squared. I should write that for this one, too. All right? Awesome. We're getting there, guys. We're getting there. I think I'm doing a little better for time. Okay. Next picture, this heart picture. I'm seeing 3 shapes. Okay, I see 1. I'm going to keep with the same color. Hopefully you guys know why I'm keeping with the same color for those 2 semicircles. And then I'd have this square in the middle be shape 3. So why did I use the same color for 1 and 2? Guys, those are the same shape. So I'm only going to solve for this shape one time. All right, I only want to solve for this shape one time. How do I know they're the same? Well, they're both semicircles, and they're both going to have diameters of 3, right? If this is 3, then this is 3. If this is 3, then that's 3. Okay? They're going to have the same radius. They're going to have the same area. So what I'm going to go ahead and do is I'm going to say 1 and 2. All right? 1 and 2 uses A equals pi r squared divided by 2. All right? So, area equals pi. What am I going to use for radius? Well, if this diameter is 3, then I have to use half of it, or 1.5. 1.5 squared. A equals 2.25 pi. Still got to divide by 2. A equals 1.125 pi. All right, now that's for one of them. That's for 1 or 2. What am I going to do if I want to get the total area of 1 and 2? Well, all I'm going to do is multiply by 2 again. All right, so it turns out that if you just kind of connect these, you can almost treat it as a full circle. If you have 2 semicircles, you can treat it as a full circle. So when I multiply by 2, I actually go back 2, and I'm going to kind of come up here to save some room. This is going to give me 2.25 pi. All right, now that is for both semicircles. Last thing we need, and I don't think this will be too tricky, but if we need the area of that square, well, we can use base times height because it's a rectangle or a parallelogram. The other thing you can do is because the square has the same sides, all the same sides, you can always use side squared. All right, I know we didn't give you that one, but hopefully you guys kind of can make some sense out of that. So a equals 3 squared, or a equals 9. All right, so here we go. We're going to add everything up because it's composite. 9 plus 2.25 pi, and those would be in inches squared. Or again, the decimal approximation, you go to the calculator, 9, 2.25 pi, 16.1. All right, 16.1 inches squared. Both answers more than okay with me. Okay. All right. So those were 4 examples of addition. Now what I want us to do is take a look at 5 and 6 in the next page, and notice that these are actually going to be. Oh, this isn't working. I'm going to fold over. Sorry, guys. All right. These are ones where we're going to have to subtract. Okay. What I want you guys to hopefully notice here. What I want you guys to hopefully notice here is that I have this entire shape that I can call a rectangle. And then what I'm actually going to do is I can take away that semicircle and that semicircle, and that's going to leave me with the area that I want, right? So what I'm going to do is I'm going to say that my big rectangle, the whole thing, is my shape 1, and then here are my shape 2s. All right, I'm going to just label them both 2s because they're the same thing. All right, so to get the area of shape 1, a equals, rectangle would just use base times height. So a equals base of 33, height of 16, calc it, 33 times 16, 528. Area equals 528 feet squared. Now remember, that's the entire rectangle. I need to get rid of the shaded part, okay? So let's get the area of one of them, all right? Area equals pi r squared. And then again, I'm going to have to divide by 2 because I want a semicircle for right now. Area equals pi. I'm going to use 8 for my radius. Why? Because the diameter is 16. 8 squared all over 2. Area equals, well, this is going to be 64 pi divided by 2, or area equals 32 pi. Now, the last thing you have to kind of think about here, I'm doing 528, and then I'm going to take away 32 pi for one semicircle, and I'm going to take away another 32 pi for the other semicircle. So this turns out, if you want to write it in exact, you could write 528 minus, sorry, I'm having trouble with this, 64 pi, and that would be in feet squared. Okay, if you want, you can go ahead and get the decimal approximation, 528 minus 64 pi. Perfectly acceptable answer, 326.9. 326.9, also feet squared. Okay? Awesome.